Hi, these notes are actually going to go on page 23 instead of 24, so please make sure you get it on page 23. And our goal is I can find the distance between 2 points on a coordinate plane. The first one says to draw a right triangle with the segment KL as its hypotenuse, and then find the lengths of the legs of the triangle. So you're going to have to be careful to draw yours just like mine if you want your numbers to work out like mine. So if KL is the hypotenuse, then what I need you to do is draw KM being 1, 2, 3 blocks away, and ML being 1, 2, 3, 4 blocks away. So make sure you have MK being 3 away from each other and ML being 4. So then you have found the lengths of the triangle, they're 3 and 4. So then you could use the Pythagorean Theorem, a squared plus b squared equals c squared, with your two lengths. So if this is 3, you'd have 3 squared plus 4 squared equals c squared. Again, using the lengths of your triangle. 3 squared is 9, 4 squared, 4 times 4 is 16. Bring down your c squared. 9 plus 16 is 25. 25 equals c squared. And then over here, in order to get c by itself, you're going to have to square root c squared. So the square root of c squared is c. Whatever you do to one side, you got to do to the other. So the square root of 25 is 5. Since we're talking about lengths, you don't have to worry about the negative of the square root because you can't go a negative distance. So the hypotenuse, KL, would be 5 units apart. Okay, now moving on to M and N. So I drew this one up in this far corner. I made MO be 5 away from each other. 1, 2, 3, 4, 5. And ON to being 9 away from each other. So ON needs to be 9. Now, use the Pythagorean Theorem to find the length of the hypotenuse MN. So you have your a squared plus b squared equals c squared. Your a squared, that was the distance of 5. So you have 5 squared plus, this had the distance of 9. So 9 squared equals c squared. 5 squared is 25. 9 squared, which is 9 times 9, is 81, equals c squared. When you add those two up, you get 106. When you take the square root of c squared, because you need to make it to where c is by itself, the square root of c squared, or the square root of 106, is going to give you pretty close to 10.3. So remember, we use the wavy equal sign to show that it's approximately. C is approximately 10.3 units. So that is your hypotenuse. The next one, we have PR and PQ. So PQ is your hypotenuse. So you're trying to find how far away they are from each other. So to do that, you can count your PR is the distance of 2, and RQ is the distance of 9. So again, you can plug those into the Pythagorean Theorem. 2 squared is 4, 9 squared is 81, equals c squared. 4 plus 81 is 85, so then you get 85 equals c squared. And then to solve that, to get c by itself, you got to take the square root of both sides. The square root of 85 is going to get you pretty close to, so you'll see the approximately sign, 9.22. Then when we look at D, let's see if I can zoom out here. When we look at D, they give you T and U on here. So T down, you want to count, and that is 1, 2, 3, 4, 5. So the length of T to, I can't see what mine thinks that's down here, is 5. And then over here to U is 1, 2, 3. So that distance is 3. So you can plug that into the Pythagorean Theorem, and you can find that the length TU is 5.83. And then when you look at the last one, it's a little different. It says find the coordinate of 2 points that's a square root of 13 units apart. So you kind of have to think backwards for these. So if you know that the coordinates need to be the square root of 13 apart, you're going to start down here. So if c equals the square root of 13, think about what you would do to go up a step. You would want to square both sides. So when you square c, you get c squared. When you square square root of 13, you get 13. Now you want to think about what are two perfect squares that would add up to be 13. So remember, when we think perfect square, we think what times itself will give you that number. So you could think about 1 times 1, 2 times 2, 3 times 3, 4 times 4. Well, when I think about those, I know that 4 plus 9 equals 13. So then I know that c squared would equal 4 plus 9. Going backwards again, that would tell you that a squared would have to be 2 squared, because if a squared is 4, then it would be 2 squared. B squared would have to be 3 squared. So it's like you're doing a Pythagorean theorem problem backwards to find two spaces that are a square root of 13 apart. So now you have it all plugged in to the Pythagorean theorem, and you know that your lengths are 2 and 3. So whatever triangle you draw, you know that if you make one of the legs of the right triangle to be 2, the other leg to be 3, then the hypotenuse is going to be the length square root of 13, because that's what would happen if you put it in the Pythagorean theorem. Hope that helps, and those are your page 23 notes.